All right, number 25 gives us this relation, and it says uh, they said x and y are real numbers, graph it and tell whether it's a real function. Okay, so let me just draw a rough graph here. We had a problem back up in number 7 on this same section. I think 7 and 9, or 7, was not a function. And part of the reason it wasn't is because it had absolute values on both sides. Now, if you have absolute values on one side and it's on the x, usually you got a function, okay? So let's kind of think about this. Let's pick some x's and plug them in. It's not going to take too many of them. I think the best way to do this is with a table. Let's pick the numbers that we're used to kind of knowing we should be graphing if we're graphing from a table. So we would have the negative absolute value of -2 if we plugged in -2, which inside the whole absolute value thing would give us a 2, but there's a negative out front, so we'd get -2. So we've got the point -2, -2. Let's say it's right there, okay? I'll put some other little lines that we're not going to need a lot here. What about, okay, so for the y, it's negative absolute value of -1. Well, you write the negative out front down, but the absolute value of -1 is 1, so you get -1, -1. So that would be right here. Okay? Then we got the negative absolute value of 0. That would be negative. The absolute value of 0 is 0, but that's just 0. So we got 0, 0, which is right here. Okay, then we've got the negative absolute value of 1. Well, that's -1. So that's the point, 1, -1. Oh, that's right here. Let me make that one a little bit bigger too. Now on 2, you got the y value is the negative absolute value of 2, which is -2. So you got the point 2, -2. Now if I join these together and show you the graph, I'll do that in red just so that it stands out. Here's the graph of that. Oops, I missed it, but you know what I mean. It's right there. All right. Is that a function? Well, the vertical line test says if I draw a vertical line through every point there, I'm just only going to hit through the graph. I'm only going to hit one point on the graph for every vertical line I draw. And again, if you're not getting what I'm saying, I'll just go ahead and do some vertical lines. You see how we're only hitting one point anywhere we draw it. So is this a function? Yes, it's a function. And let's see, were we supposed to answer anything else? We were supposed to graph it and tell whether it's a function. So yes, it's a function. On here is number 27 on 3.10, and you get, again, if this notation is throwing you for a loop, they're just telling you have points. They have an x and a y in them. And your equation is y equal 1 minus absolute value of x. And again, we can always, if we don't know how to do it any other way, we can always graph from a table. So again, a lot of times when we're doing that, we just usually pick these numbers unless they're not so helpful, and there's times there's not. By the way, we're going to learn another way to graph this eventually. Okay, so this is, if I want to fill in the y values, it's 1 minus the absolute value of -2, which is 1 minus 2, because the absolute value -2 is 2. 1 minus 2 is -1. So let's just graph as we go, and again, I know it's not a great graph, but, you know, we'll just do a little sketch of a graph over here. All right, so I've got the point -2, -1, so that'd be about right here. Then on the next one, y is equal to, let me just alternate colors so you can tell what goes with which problem. I'm doing -1 now. 1 minus the absolute value of -1. The absolute value of -1 is 1, and 1 minus 1 is 0. So at -1, I've got 0 there. Okay. On the next one, doing the 0, plugging in 0 for x. 1 minus absolute value of 0 is just 1 minus 0 is 1. So at 0, we're up at 1. And I'll go back to blue here. Plugging in 1. 1 minus the absolute value of 1 is 1 minus 1, which is 0. So at 1, we've got 0. And then going for x equal 2, 1 minus absolute value of 2 is 1 minus 2, which is -1. So we've got the point x is 2, y is -1 here. And if we connect these, and again I'll do that in red just so it really sticks out, we get this shape. It's a V shape. but it's upside down and the reason is, I want you to think about this a minute. What if I put a plus out here and I rearranged this? I could think of this as adding a negative absolute value of x. Subtracting and adding a negative are the same thing. I would have negative absolute value of x plus 1 if I rearranged it. Just so you kind of know, this absolute value of x is a V shape. It opens up, but this negative flipped it downward. So you could do this in your graphing calculator. You could actually graph, like take this in steps and graph at y equal absolute value of x. Then you could graph y equal negative absolute value of x. And if you did that, you'd have something that looked like this, okay? But then when you add the 1 to it, if you did all this on your calculator, you can see kind of how you can break a function apart a little bit. If I add 1, that scoots it up so that now it's that red graph that I drew. Or we could graph it from points. I just want to go ahead, for those of you who might be interested, and kind of explain to you how eventually we're going to look at this. Okay, so is this a function? I didn't answer that question. Yes, it is. And the reason it is if we use the vertical line test on the red line, that's the real graph here. You're only going to hit 1 point on the red graph anywhere you draw a vertical line. So yes, it's a function.